Hi, I'm Zhang from Fudan University. Now I'll present our work, Demystifying the Insecurity of QR code-based login in real-world deployments, in collaboration with Yat-sen University. Over the next few minutes, we'll see why an authentication method that feels convenient and secure is, in practice, surprisingly fragile. Many of you have probably used QR code login before. It has become common in our digital lives. WhatsApp, Taobao, Steam, Telegram, millions of users log into the websites by scanning QR codes. Essentially, QRLogin is a type of cross-device authentication. Simply scanning a QR code with your trusted mobile app, you can conveniently log into the website. No typing, no password. Looks safe, but here's the catch. There's no implementation standard. Every site builds it their own way. As a result, the security of QR login varies a lot. To see what can go wrong, here's a real-world attack we discovered. In a user's normal QR login process, the browser keeps polling the server, asking, has the QR code been approved? But if an attacker steals the QR code, say by pseudo surfing or using a malicious extension, they can also start polling the server. The attacker now joins the same question and answer game and can ask faster to reach again the victim. When the victim approves the login on their phone, both sides are polling, but the server gives access to whoever's faster. So, with a quick burst of requests, the attacker wins, hijacking the authorization and walks into the victim's account. In this paper, we conduct the first systematic study of QR login security in the real world. We start by analyzing how QR login is actually implemented. Based on that, we discover 5 new types of attacks in QR login. To see how serious the problem is in the real world, we build tools to test real websites at scale. And finally, we provide auditing tools and best practices for developers and users. It's important to know that our focus is on how websites design and implement QR login, not malicious QR codes or compromised devices. Okay, let's begin by looking at a simplified QR login workflow to understand how the whole process works. First, the user visits a website on their computer and initiates QR login. The site generates a unique QR code, and the browser begins polling the server to check its status. Next, the user scans the QR code with the trusted app on their phone and taps Agree to confirm. The app sends a message with the user's app token to the server, essentially saying, this user authorizes this QR code. Finally, the server replies to the browser's poll with the login token, and the user is logged in. This is a simplified view, but it captures the key actions. And for full details, please check our paper. Now that we understand the workflow, let's define our threat model. In our analysis, we assume the attacker doesn't control the victim's device, like what we said before. Instead, we focus on attackers who get limited information, like the victim's QR code on the screen or the QR ID encoded in that code by ways like brute forcing, or victim's account identifier like a phone number. These are all realistic attack services in the wild. Although it's possible to grab a QR code through ways like pseudo surfing or malicious plugins, To understand how users treat QR codes, we ran the user study and found that many users face the risk of QR code leakage when performing QRLogin, and most are not aware that leaking a QR code could be dangerous. So, this isn't just a theoretical risk, it's realistic and underestimated. Now, let's dive into how we analyze the security of QRLogin. We follow a two-step process. First, we identify the variables that are crucial for security, including session ID, QR ID, and tokens. Then, we checked whether these variables meet the core security principles: confidentiality, integrity, and consistency. Following our threat model and security analysis, we uncovered 6 security flaws, leading to 5 new types of attacks in QRLogin. Starting with session ID, we found that often isn't bound to the QR code. This flaw confuses the server, making it unable to distinguish legitimate session requests from malicious ones when polling the QR code status. And for QRID, it may be reusable, predictable, and controllable, and attackers can exploit it accordingly. Token verification might be weak, allowing attackers to impersonate users. I will detail these attacks later, explaining how they work and impact on QRLogin security. To understand the broader picture, we structured our analysis around 3 research questions. First, how is QRLogin used in the world? We collect 350 websites using QRLogin from the Tranco top 100,000 and found QRLogin is more common on top-ranked sites, and they often belong to security-sensitive categories like technology, business, and shopping. So, even if QRLogin isn't everywhere, well, it appears it really matters. Next, are these real-world QRLogin systems secure? To answer this, we built a semi-automated testing pipeline. It captures traffic, analyzes behavior, and checks for the flaws we identified before. Using this pipeline, we analyzed 109 testable QRLogin websites. The results are concerning. 43% of them had at least one serious security flaws, affecting millions of users. We responsibly disclose the issues to vendors and official vulnerability platforms, along with suggested fixes. So far, we've received 42 confirmed vulnerability IDs. Now, let's walk through a few of the attacks we found in the real world. The first is the authorization hijacking, which is the motivating attack mentioned at the beginning. It happens when the QR code isn't bound to the browser session. An attacker who steals the victim's QR ID can poll faster to race against the victim and log in before the victim. The attacks works because the server never checks who originally initiated the QRLogin. It just trusted the one who got the QR ID. We found this vulnerability in multiple major websites, such as major shopping sites with over 500 million users, exposing private order histories, personal information, and so on. Based on the attack one, let's look at what happens when there's an additional flaw. Flaw 2, reusable QR code. This means once the victim logs in, the QR code's authorization isn't cleared. So the attacker doesn't need to reach anymore. They just wait for the victim to finish logging and then quietly pull the same QR code. This lets the attacker log in simultaneously with the victim, taking over the account without the victim ever knowing. We also found this attack in many popular websites, such as a social media website within the top 500. This will allow attacker to monitor victims' social activities, perform malicious actions, and so on. One more, universal account takeover attack. This one is particularly alarming. Here, the server fails to verify the app token and only checks the account ID, like a phone number. That means attackers can log in as any user just by knowing their phone number. We found this on the popular cloud storage service, giving access to private files and sensitive data. This is a stark reminder that even a simple flaw in identity verification can have massive consequences. To wrap up, we've identified these risks. The last argue is to enhance the security of QRLogin. First, for developers, we designed auditing tools called QRL Checker, which can be used by developers to check their QRLogin implementations. It will report the existing flaws and the corresponding fix measures. It's now responsibly available on request to vented ones to prevent misuse. On the other hand, we also provide security suggestions to make your login process more safer. There's more in the paper, including more attack types, case studies, and technical discussions. Feel free to check our paper. Thank you.